આપણે અહીંયા જે ચેપ્ટર લેવાની છે એની શરૂઆત કરીએ છીએ. થોડીક માહિતી આપી દઈએ. એક જ મિનિટ. તો આપણે MSc SEM 3 આપણે ચાલુ કરીએ છીએ. MSc SEM 3નો આ પહેલો જ લેક્ચર છે અને પહેલા લેક્ચરમાં જે સ્ટેટિસ્ટિકલ મિકેનિક્સ આપણે ચાલુ કરીશું. જોઈએ આપણે સ્ટેટિસ્ટિકલ મિકેનિક્સમાં આપણે કયા કયા પોઈન્ટો છે એ આપણે જોઈશું. જો શરૂઆત કરીએ છીએ આપણે સ્ટેટિસ્ટિકલ મિકેનિક્સની અંદર, તો પહેલો પોઈન્ટ આપણે જોઈએ તો એના અંદર આમ આ જે પેપર જે છે એ બે ભાગમાં વહેંચાયેલું છે. પહેલું જે પેપર જે છે એની જે વાત કરવામાં આવે છે, ફરી પાછો આગળ બીજા પેપરની વાત કરીએ છીએ. તો શરૂઆત તો હવે SEM 3માં જે નવા ટૉપિકની જે વાત કરીએ છીએ એ આપણે જોઈએ છીએ. તો આપણે ફિઝિક્સમાં 302 જેનો કોડ નંબર છે MSPHY 302CC, તેમજ અહીંયા સેમિસ્ટર 3 જે આપણે કહીએ છીએ. હવે એના અંદર જે શરૂઆત કરીએ છીએ કે કયા કયા ટૉપિકનો મતલબ કે લેવાના થશે આપણે, તો પહેલાં તો આપણે ફેઝ ઇક્વિલિબ્રિયમ, બીજા નંબરમાં ટ્રાન્સપોર્ટ ફિનોમિના, બીજા નંબરમાં આપણે અહીંયા ટ્રાન્સપોર્ટ ફિનોમિના લઈશું. આ રીતે જુદા જુદા પોઈન્ટ આપણે લઈશું. અહીંયા જોઈએ છે તો પહેલો પોઈન્ટ ફેઝ ઇક્વિલિબ્રિયમ, બીજા નંબરમાં ટ્રાન્સપોર્ટ ફિનોમિના, ત્યારબાદ ત્રીજો પોઈન્ટ લઈએ તો અહીંયા માઇક્રોસોફ્ટ એક્સેલ. જે આપણે MSc SEM 2માં જે તમને મેં ભણાવ્યું હતું, પાવર પોઈન્ટ સમજાવ્યું હતું, વર્ડ સમજાવ્યું હતું, એ જ પોઈન્ટ આપણે અહીંયા લેવાનો છે. અને એના પછી આપણે જે ચોથા નંબરનો યુનિટ જે છે એ પણ હાલ જ આપણે ડિસ્કશન કરીએ છીએ. તો હવે ચોથા નંબરના યુનિટની વાત કરીએ. તો આ ચોથા નંબરના યુનિટની વાત છે. ચોથા નંબરના યુનિટની અંદર જોઈએ આપણે શું લઈશું તો કોમ્પ્યુટર નેટવર્ક એન્ડ ઇન્ટરનેટ એન્ડ વાયરસ. ટૂંકમાં આપણે MSc SEM 3માં 4 યુનિટ લઈશું. MSc SEM 3ની અંદર 4 યુનિટ લઈશું અને 4 યુનિટ આપણે મતલબ કે અહીંયા વિચારીશું, આગળ બને ત્યાં સુધી સમજવાની આપણે કોશિશ કરીશું. તો જો રેફરન્સ બુક કઈ છે, તો રેફરન્સ બુક પણ એક વખત તમે જોઈ લો તો તમને ખ્યાલ આવી જાય. તો જો પહેલાં ફંડામેન્ટલ ઓફ સ્ટેટિસ્ટિક્સ, BB લાઉડ. હંમેશા BB લાઉડની બુક્સ તમે SEM 6માં 5-6માં પણ વાપરી છે. ત્યારબાદ સ્ટેટિસ્ટિકલ મિકેનિક્સ ઓફ મેટર્સ બાય ES રાજા. ત્યારબાદ ઘણી બધી બુક્સ છે. અહીંયા કોમ્પ્યુટરની અંદર જો કોમડેક્સ કોમ્પ્યુટર કોર્સ કિટ બાય વિકાસ ગુપ્તા, પછી ફંડામેન્ટલ ઇન્ફોર્મેશન એન્ડ ટેકનોલોજી દીપિકા, બરાબર, ડૉક્ટર બાય દીપક, બરાબર. એ પ્રમાણે થોડાક અક્ષર નાના છે એટલા માટે થોડીક તકલીફ પડે છે. તો આવા જુદા જુદા પોઈન્ટ આપણે લઈશું. તો એના પછીનો ટૉપિક આપણે લઈએ છીએ. સૌથી પહેલો જ આપણે સ્ટેટિસ્ટિકલ મિકેનિક્સથી શરૂઆત કરીશું. સ્ટેટિસ્ટિકલ મિકેનિક્સ જુઓ, શરૂઆત કરીએ છીએ આપણે સ્ટેટિસ્ટિકલ મિકેનિક્સથી. ચલો. નોટ ને પેન તમે તમારી સાથે રાખજો તો તમે આ સમજી શકશો. સૌથી પહેલાં શક્ય એટલી આ બુક્સ તમે લાઇબ્રેરીમાંથી લઈ લેજો. હવે સૌથી પહેલો પોઈન્ટ જે છે ફેઝ ઇક્વિલિબ્રિયમ. તો ફેઝ ઇક્વિલિબ્રિયમ કોને કહીએ છીએ તો એની વાત કરીએ. In this chapter we will concern with the systems comprising several phases in equilibrium for one another. Okay, so now we study many types of phases. Okay, but in the case of equilibrium, and what is the relation between the phases with one another, so we will study in this chapter. The name of the chapter, that is the phase equilibrium. Now first of all the question arises, what is the phase? What is the meaning of phase? Phase, it is a homogeneous portion of a system which exhibits a macroscopic behavior different from that of the other parts of the system and is separated from them by a well-defined boundary. So now we means the homogeneous portion. So now same types of particles, that is the homogeneous. Okay, suppose the H2, O2, N2, so these are the homogeneous particles. But now in the case of heteroparticles, the HCl, H2O, NO2, these are the heterogeneous particles, heteroparticles. So now which exhibits a macroscopic behavior. Okay, they behave as the macroscopic behavior. You know, there are two types of macroscopic and microscopic. In the case of microscope, we study the micro change of the physical quantities, very micro, very few, very micro change. And now in the case of macroscopic, there is a large physical quantities. Okay, suppose the temperature of the room, pressure of the room, so this is the macroscopic particles. But in the case of, if we study the temperature of each and every particles, that is known as the microscopic particles. Pressure of each and every particles, that is known as the microscopic particles. So now our aim to explain what is the phase. The V means that is a homogeneous portion of a system which exhibits a macroscopic behavior. How it is behave as the macroscopic behavior, different from that of other parts of the system. They are isolated, they are differentiated by the other particles of the system. Okay, so now phase is differed by the other parts of the system and is separated from them by a well-defined boundary. You know, we consider the phase only. It is separated by the others and it is well-defined boundary. Phase is exactly isolated from the other system. Okay, so now this is the property of the phase. Several phases of a system may coexist in equilibrium with one another. Okay, it may be happen the two phases. Okay, a system has two phases and they coexisted. Both are simultaneously appear. Okay, and they are in equilibrium. What is the meaning of equilibrium? If two systems both are isolated and having temperature, pressure, volume, every physical particles, every physical quantities are same, then they are known as the equilibrium with one another. Suppose we will take the examples. Okay, now let us take the examples. Examples of the two phase systems are examples, a liquid and its saturated vapor. Okay, suppose a liquid is heated, obviously the temperature of the liquid is increased, but now if you constantly supply the heat to the liquid, then if the temperature of the liquid is more than boiling point, okay, then it is converted into the vapors. So now here there are two systems, one is the liquid and second is the vapor, a liquid and a crystal, etc. Again I read, examples of two phase systems are a liquid and its saturated vapor. Suppose water is filled in the vessel and this water is heated. So now up to 100 degrees Celsius there is no conversion of liquid to vapor. but now more than 100 degrees Celsius, some amount of liquid is converted into vapor. So now there are two systems. One is the liquid and another is the vapor. And mind well, that is the saturated vapor. Okay, a liquid and a crystal, etc. In general, okay, each phase may contain several components. Each phase, okay, every phase in the system may contain several components. Example, the several different species, okay, several different species or molecules or ions. Okay, suppose we consider the phase of the molecules, okay, or we can say we consider the case of the water. So now hydrogen and oxygens, there are components, and these components are, okay, in the vessel. We say one component system can exist in different phases, gases, liquid, or in crystalline form. Okay, so now suppose you know the component of the water. Suppose you consider water. So now they exist in three different phases. One is the gaseous or liquid, or you can say the solid like ice. In a system whose phases are in equilibrium, a slight variation of external condition result in a certain amount of substance passing from one phase to another, as can be observed. For example, okay, in a system whose phases are in equilibrium, suppose there are two phases and they are in equilibrium, a slight variation of external condition, okay, two phases, one phases and second phases, temperature, pressure, all the physical quantities are same for these two cases. But now out of these two phases, in one phases, suppose that slightly variation of the temperature, then what happen? Okay, we will study that in a system whose phases are in equilibrium, a slight variation of external conditions result in a certain amount of substance passing from one phase to another, as can be observed. So now what happened? Again I understand, explain you. Suppose two phases and both phases are in equilibrium. Okay, both phases have all the physical quantities are the same. But now if one of these two phases, the temperature is slightly differ, then this phase is converted into another phase. Okay, in a system whose phases are in equilibrium, a slight variation of external condition result in a certain amount of substance passing from one phase to another, as we can observe. For example, in the fusion. Okay, for example, what happen in the case of fusion or boiling of water? Now, first of all, what is the fusion? What is the fusion or what is the boiling of water? Now, you know, if vapor is converted into the water, okay, if vapor is converted into the water under the certain physical circumstances, then it is known as the condensation, or you can say fusion. Means the vapor is converted into water. And now what is the boiling point of the water? It is easy. Okay, the water is converted into vapor. This process is known as the phase transition. This known as the phase transition means the formation of the matter is changed to the other formation in the other forms. If solid is converted into the water. Suppose ice is converted into the water, so ice is the one type of phase and water is the another type of the phase. If water is converted into the boiling vapor, then again the second phase is converted into third phase. So now this is the explanation of the phases. This process is known as the phase transition. Okay, this is known as the phase transition. Again I explain you if solid ice is converted into water, then it is known as the phase transition. If water is converted into the vapor, then this is the phase transition. The study of transition region between phases is one of the most interesting field of the statistical physics, and hence while studying the condition of phase equilibrium, we will also consider the development of the phase transition. We shall describe the phase transition in terms of macroscopic variable. This topic is also more important. What is the aim of this chapter? The aim of this chapter, that is name of this chapter, that is the phase equilibrium. But aim of this chapter, we will study when if a variation from one phase to another phase, so how it is transferred from one phase to other phase, which conditions are required for the transformation for one phase to another, okay, that we will study, but in the case of macroscopic variables. Again I explain you what is the macroscopic variables. If the physical quantities like temperature, pressure, okay, these all physical quantities are applied to the entire matter, then it is known as the macroscopic. But now what is the microscopic? So if temperature, pressure, these type of physical quantities are applied to the each and every molecules of the state of the phase, then it is known as the microscopic variable. You have studied this macroscopic and microscopic SEM 5 BSc. So now we will also consider the development of the phase transition. Okay. Now the first topic, equilibrium condition. જો અહીંયા મેથેમેટિક્સ આવશે એટલે મેથેમેટિક્સ પણ સાથે સાથે તમારે સ્ટડી કરવાનું છે, એ પણ જોતા રહેવાનું છે. લેટ અસ ફર્સ્ટ derive the conditions under which different phase can exist in equilibrium. Okay, let us first derive. We will derive the conditions under which different phases can exist in equilibrium. Suppose two or more than phases are given and they are in equilibrium condition. So we will study in which conditions, okay, in which condition they remain in equilibrium. Means all the phases remain in equilibrium. In these circumstances, we will study the conditions so that no transfer of matter take place from one phase to another. Again I explain you. Suppose x and y both phases are given. X and y both phases are given. Now we will study which are the conditions so that x phase and y phase do not transfer to the other phases. X phase remain X phase and Y is always remain Y phase. Now figure 11.1. Okay, so now we see the figure 11.1. Now the figure 11.1, this is the 11.1. Here the energy E1, number of particles N1, and volume that is the E1 N1 V1, and here that is the E2 N2 V2. So obviously there are two phases. Each phase has the energy, number of particles and volume thrice are different, and our aim is to maintain these phases always in the same phase. Okay, our aim is the phase is not transferred to the other phases. Okay, so that we derive the sum equation. Okay, so now erase all, and now the first slide, we see the first slide. This is the first slide. Now first slide in figure 11.1. Okay, two phases, energy, volume, pressure, okay, all are equal, and the system is isolated from its surrounding and its energy is E. There are two phases. Mind well, there are two phases, and this system having two phases is isolated from its surrounding, means they are not affected by the surrounding temperature, surrounding pressure. These two phases in the systems are invariant. Okay, they are isolated, and its energy is capital E, volume V, and number of particles N. Okay, total energy E, volume V, and the number of particles that is the N. So now the quantities associate with the two phases, that is the E1 N1 V1 and E2 N2 V2. Mind well, again I explain you, there are two phases. The total energy of the two phases, that is the E, total volume, that is the V, total number of particles, that is the N, and the corresponding the quantities for the first phase E1 V1 N1 and the second phase, that is the E2 V2 N2. So now obviously the 11.1 equation, E is equal to E1 plus E2, V is equal to V1 plus V2, N is equal to N1 plus N2. So now here we discussed the two phases, conditions of the two phases and equilibrium condition. In next lecture, okay, we will study about the mathematicals, and for that મેથેમેટિક્સ માટે તમારે નોટ ને પેન લઈને જ બેસવાનું, અથવા તો તમે આ બુક આખી નેટ ઉપરથી ડાઉનલોડ કરી દો અને એની ઝેરોક્સ કરાવી દો અને એની સાથે લઈને તમે બેસો મોબાઈલની સાથે, તો તમારે લખવું નહીં પડે. અને આ રીતે આપણે અહીંયા પૂરું કરવા માગીએ છીએ. તમને કોઈ ડિફિકલ્ટી હોય તો મને વોટ્સઅપ નંબર ઉપર જાણ કરવાની. મારો નંબર છે 9974712324. આ મારો વોટ્સઅપ નંબર છે. તમને કોઈ મુશ્કેલી હોય તો, જો આપણે ફિઝિકલ ક્લાસરૂમમાંથી ઓનલાઈન ક્લાસરૂમ મતલબ ઓનલાઈન સમજાવવા માંડ્યા છે, થોડીક મુશ્કેલીઓ તો થશે, પણ જે કંઈ તમને મળવાપાત્ર છે, જે કંઈ મળે છે એમાંથી તમારે મતલબ કે તૈયારી કરવાની છે. એટલે આ પ્રમાણે આપણે અહીંયા ફર્સ્ટ લેક્ચર અહીંયા પૂરું કરીએ છીએ. ડિફિકલ્ટી હોય તો તમે મને વોટ્સઅપ નંબર ઉપર પૂછી શકો છો. ઓકે, થેન્ક યુ વેરી મચ.